CORS is a security feature that is built into the web browsers like Chrome, Firefox. Regardless of what type of browser that you're trying to use, all these browsers, they are going to have an inbuilt security feature. Due to this security feature only, we are getting these CORS error when a front-end application is trying to communicate with a back-end application. What is the full form of CORS? Cross-origin resource sharing. Origin is nothing but a domain of an application. If two different applications which are having different origin or different domain, if they're trying to share the resources with each other, under such scenarios, this CORS is going to come into picture. That's why this name of cross-origin resource sharing came. Let's try to understand why we are getting this CORS error. In our scenario, a front-end application which is running at localhost 5173 is trying to communicate with another backend application which is deployed at the port 8080. Technically, these are two different applications which are not deployed under a single server. How my browser will know that these are two different applications? Because the port numbers are different here. Though the host name is same, since the port numbers are different, the browser will assume these are different applications which are deployed at different locations. Whenever applications that are deployed at different locations are trying to communicate with each other, browser is going to stop that communication for security reasons. Imagine inside your browser there are multiple tabs. Inside the tab 1 you have open Netflix, and inside another tab you have opened some evil website. This evil website is developed by some hacker. So this is tab 2 and this is the tab 1. If there is no CORS feature available inside the browser, in these kind of scenarios, what is going to happen is these hacker websites, they should be able to read the data which belongs to the other website inside your browser. Usually inside our browser, all the websites, they are going to store some cookies, some session related data or some user related information. All such details can be read by other websites if this CORS is not available inside the browser. Since this is a serious security problem, this CORS is built as a security feature inside the web browsers. So don't assume that CORS is a security threat. Instead, it is a protection from the security threats. The CORS error that we receive, it is also conveying this message very clearly. Access to fetch the API at so-and-so backend from origin, which is the React UI origin, has been blocked due to the CORS policy inside the browser. With this discussion, you're going to get an immediate question, which is, what if there is a valid scenario where two different applications want to communicate? Under such scenarios, we need to make some configurations on the backend so that this CORS policy is not going to be a problem for such scenarios. Inside the second slide, I have shared more details under which scenarios the CORS policy error is going to come. The browser will identify origins as different if any of these parameters are different. For example, if one application is using HTTP and the other application is using HTTPS, then browser will assume two different applications are trying to communicate. The same applies for different domain names and port numbers. Even if one of these parameters satisfied, browser is going to stop the communication between two different applications. Here I have given different example. The UI app is deployed at a domain, domain1.com, and it is trying to communicate with another application which is deployed at the domain2.com. Since the host names are different, the communication is going to be blocked by the CORS. Now let's try to understand how to fix CORS in a valid scenario. Whenever an UI application wants to communicate with a backend application, the backend application should give the permission. Why backend application? Because backend applications are responsible to handle the data, to store the data inside the database. Inside the UI application, there won't be any security. Anyone can see the source code, anyone can change the source code. The data that we store inside the backend database, it is never going to be visible to the end users. That's why backend has to give permission to the UI application to communicate with it. Let's try to understand how backend can give permission to an UI client to establish the communication. When we are building a backend application using Spring Boot, there are multiple approaches on how to fix this CORS problem. The very first approach is by using cross-origin annotation. This approach is going to be simple and it's very quick. You just have to mention these annotation on top of your controller class or on top of your REST API method. To this cross origin annotation, you need to pass the domain details of your UI application. Here I'm trying to pass the domain details of my React application. With this, my backend application is giving permission only to this domain or only to this origin to communicate with this REST API method. If you mention this cross origin on top of your controller class, then you're giving permission for all the REST API methods available inside your class. But here you may have a question, which is, how does my browser will know about these permissions provided by the backend server? Let me explain you the same. Whenever two different applications are trying to communicate with each other, the browser, it is going to send a pre-flight request to the backend. So this is not the actual request. It is the pre-flight request that is going to happen just before the actual request. As part of this pre-flight request, the browser is going to ask the backend server, are you fine to make communication with so-and-so application? To this pre-flight request, as a response, the backend application, it is going to send some headers inside the response. In those response headers, these allowed origin details will be present. If the allowed origin details are matching with the UI application, then browser is going to make the actual request to the backend application. In case if there are some failures at the pre-flight request itself, then you're going to get CORS error inside your browser. This is what happening right now in our scenario. The browser is making a pre-flight request to the backend application. Since on the backend side, we don't have any CORS configuration, then it is throwing this CORS error. This is one option that you can use to fix the CORS error. But in real applications, you may have hundreds of controller classes where you might have developed hundreds of different REST APIs. Mentioning this annotation on top of all those classes will be a cumbersome and tedious process. In future, if you want to change the origin details, you need to visit all those controller classes and change in all those places. That's why for larger applications where they have good amount of controller classes or REST API methods, there is a better approach available. As part of this option 2, we need to build a filter inside our Spring Boot application. So first you need to write a class. On top of this, you need to mention configuration annotation. Next, you need to define a method which should return the CORS filter as a return type. On top of this method, you need to mention this @bean annotation. When this class is executed, my Spring framework is going to create a bean of CORS filter inside my application. If you try to understand the logic inside this method, we're trying to create an object of CORS configuration. Using this CORS configuration object, we are trying to invoke various methods like set allowed origins, where we can provide list of all the allowed origins. Here I'm trying to mention a single origin details, which is the same as React UI application origin. If you want to allow the traffic from all kind of origins, then you can mention asterisk by using collections.singlelist asterisk. The same you can try to mention next to the set allowed origins. Here also, while using this annotation, if you mention asterisk, the communication is going to be allowed from all origins. Apart from origin details, we can also control for which HTTP methods the communication should be allowed. Here, using set allowed methods, I'm trying to pass this asterisk, which means for all type of HTTP methods, I want to allow the communication. In case if you are looking to allow the communication only for the get method, you need to mention those details as an input to these set allowed methods. Apart from methods, we can also define what type of header details you want to accept as an input from the UI application. Here I'm trying to define a simple single header, which is content type. Apart from this header, if the UI application is trying to send any other headers, all those headers will get filtered by the browser. By setting true to the set allowed credentials, the backend is going to allow sending the credentials or any cookie details to the backend application. Once all these configuration details are created, you need to pass these configuration details as an input to the object of URL based CORS configuration. So here, using the source.register CORS configuration, I'm trying to provide the CORS configuration. The purpose of this first parameter is I'm trying to set up this configuration for all REST API path inside my application. That's the purpose of these /2 asterisks that I have defined here. In case if you want to restrict these configurations only to few REST APIs, you can define them as well here. And towards the end, we need to create the object of CORS filter by passing the source as an input to the constructor. And behind the scenes, this object is going to be created as a bean by the Spring framework. This is the second approach, which I always recommend you to follow because this is a one-time activity. You don't have to mention cross-origin annotation on top of your controllers. There is also a option 3 which you need to use if your Spring Boot application is using Spring Security to secure the application. In the coming sections, we are going to discuss about Spring Security. During the same time, I'm going to explain about this option 3. For now, we are going to make this option 2 inside our application and establish the communication between UI and backend application. Inside the next slide, I have provided more details about what is the purpose of each of these headers. With the configurations that we have defined here, all those details will be sent to the browser in the form of these headers. I said before, the browser is going to make a pre-flight request to the backend, and the backend is going to send the configuration details inside the response headers. These are the response headers that the browser is going to receive as part of the pre-flight request. Based upon the content present inside these response headers, the browser will decide whether to make the actual API request or it should block the communication. There are some scenarios where you don't have to use the CORS configuration. Imagine both your UI code and backend code is deployed in a single application. It is completely possible inside monolithic applications. The UI code and the backend code is going to stay inside a single server. Under such scenarios, you don't have to make any CORS configuration. For example, here, the front end can be accessed using this mywebsite.com. If this front-end code is trying to make a request deployed at the same domain, then there is no CORS is required. If you see here, the domain and origin are same for both of them. I hope you are clear about CORS. Before we try to close this lecture, let me show you some funny memes around CORS. This is what is going to happen if someone is trying to make an API call without CORS configuration on the backend. The browser is going to pull back the UI application from making the API call. Few developers, they like shortcuts, and as part of these shortcuts, they're going to mention asterisk under the access control allow origin. And with that, what they're doing? They are allowing the communication from all the domains available inside the web. Can you imagine the seriousness of this configuration in a real application? It is like inviting all the hackers into your application to steal the data. So that's why don't try to make this kind of configuration. It's fine to use for local development and inside lower environments, but for production application, always mention the actual origin details. This is my favorite meme of CORS. Let's imagine this guy is the UI application and this woman is a server. In between, her boyfriend came into picture and he's stopping the communication. So who is this boyfriend? It is the browser. Just like how the browser is stopping the communication, in this scenario, this guy is trying to stop the communication between this guy and his girlfriend. I hope you like these memes.